Good morning, student. Welcome to the lecture series on strength of material. This is lecture number 2. This learning resource is basically made for the student of second year diploma in mechanical engineering under Maharashtra State Board of Technical Education. Myself, Ashish Lambe, faculty at the Department of Mechanical Engineering, KK Polytechnic, Nasik. In our first lecture, we had discussed about the foundation or basic terms associated with the subject. Some of the basic definition like stress, strength, force, mass, area, volume. In the today's lecture, we are going to discuss about type of strength, type of stress, Hooke's law, Poisson's ratio, different elastic constant, and what is the relation between these elastic constants. Now, the type of stresses. We know that stress is defined as the ratio of resistive force upon cross-sectional area. On the basic, there are basic two types of stresses. One is direct stress and another one is indirect stress. In today's lecture, we are going to focus on direct stress. So, there are three types of simple direct stresses. First one is tensile stress, compressive stress, and shear stress. Let's discuss further. What is tensile stress? Let us consider the block as shown in the figure. It is acted with a pull force P. That means tensile force P. When a tensile force acts over it, what changes will observe? That there will be elongation. That means its length increases and its diameter will decreases. That means when we apply tensile force, there will be definitely resistance, and that resistance, ratio of the resistive force upon cross-sectional area, is nothing but the tensile stress. Second one, compressive stress. It is the ratio of resistive force upon cross-sectional area when the applied force is compressive, which is as shown in the figure. Tensile force produces the elongation, while compressive force produces the compression. That means here length get reduced while diameter get increased, or a lateral dimension get increased. Tensile and compressive are the axial forces. Now this third one is the shear stress. It can be defined as a resistive force upon cross-sectional area, but now the applied force is in parallel or a perpendicular direction. It has been shown in the figure. Now, shear stress is denoted by letter T. The component which fail in shear or due to shear are called the components subject to the shear failure, and the common example are these. The next one is the Hooke's law. But before that, let's discuss the very important term, and that term is the type of strength. Basically, unlike the tensile force, compressive force, and shear force, there are three types of tensile stress, compressive stress, and shear stress. There are also basic three types of strength: tensile strength, compressive stress, and shear strength. What is tensile strength? So it is nothing but the ratio of change in dimension to the original dimension when applied force is tensile, but we can say it is change in elongation to the original length, because elongation means what? Increase in length. Compressive strength. It is defined as change in dimension to the original dimension, but here change in dimension refers to not elongation, but it is compression. Third one is the shear strength. When we apply parallel perpendicular force, the change in its angular dimension will be observed, and the ratio of the change in dimension to the original dimension associated with the angle is the term shear strength. Other than this, we have the linear strength, lateral strength, and volumetric strength. But before that, let's start the discussion on the very fundamental law, Hooke's law. It states that within an elastic limit, stress is directly proportional to strain. That means strain is given by stress directly proportional to strain. if I want to eliminate this term limit of proportionality, I can write stress is equal to constant multiplied by strain. The constant is called as modulus of elasticity or a Young's modulus. It is denoted by letter capital E. So Young's modulus is capital E is equal to sigma divided by small e, that is small e for the strain, the unit. As strain has no unit, so the unit of Young's modulus is exactly equal to the unit of stress, that is Newton per mm square or Pascal. But remember, stress is always expressed in megapascal, while not all kinds of constant, whether it is E, G or K, are always expressed in gigapascal, that is 10 to the power 3 Newton per mm square. When I say 200 gigapascal, it will be equal to 200 into 10 to the power 3 Newton per mm square. You must keep this point very well, because it is very important while solving the numerical. If you miss this conversion, then definitely your numerical will be leads to wrong answer. Next term, linear and lateral strain. Linear strain, it is defined as a change in length to the original length. It is denoted by letter E suffix L. Always remember, linearness are associated with length. What is another type? Lateral strain. It is defined as changing lateral dimension to the original lateral dimensions. It is it may be thickness, it may be width, it may be diameter. So you can say change in diameter to the original diameter, or change in thickness to the original thickness. So all these are the lateral strain. Lateral means, or a lateral dimension means the dimension at one length. Third one is the volumetric strain. It is defined as the ratio of change in volume to the original volume. It is denoted by E suffix V. So it will be change in volume to the original volume. Now, what is that relation? Which gives you idea about linear strain and lateral strain. It is the Poisson's ratio. It is defined as the ratio of lateral strain to the linear strain. It is denoted by letter mu. So mu or Poisson's ratio is given by the ratio of lateral strain to the linear strain. Generally, the value of mu varies between -1 to 0.5. The value may be 0 or value may be negative. There are three constants. Already we have discussed modulus of elasticity, load, modulus of elasticity. So let's discuss another term, other elastic constant. First one is modulus of rigidity. It is the ratio of shear stress to the shear strain. We know that corresponding to shear force, there will be shear stress and shear strain. So if I took the ratio of these two terms, shear stress and shear strain, I can call it as a modulus of rigidity, and it is generally denoted by letter capital G or capital C. Most of the cases it is denoted by capital G, but in many cases, if you refer some of the references, you will find some of the author denoted with a capital C. So modulus of rigidity is the ratio of shear stress to the shear strain. It is very important in the study of torsion. T by J is equal to G theta by L is equal to O by R. It is the torsion equation, in which G is what? Modulus of rigidity. So if I want to find diameter, if I want to find out the power transmitted, if I want to find out the torsion, I must have the sound idea of this term modulus of rigidity. Next one is the bulk modulus. It is the ratio of direct stress to the volumetric strain, and it is denoted by letter capital K. So bulk modulus is a direct stress to the volumetric strain. Generally, already I had discussed, modulus are expressed in terms of GPa. So E, G or K are always expressed in GP. One more thing associated with the bulk modulus, that the significant it has a significant relevance in a fluid mechanics. So in a fluid mechanics, there is one term, compressibility. How we can understand the compressibility? When we say what is compressible, so let us take the example of water and gases, or water and air. We can say water is incompressible because when I apply force over the water, there is a negligible deformation. But when I apply force on the air, if I took the gas in any cylinder, and I can say I can compress gas. It is compressed natural gas, so gas can be compressed. So there is a term compressibility, and this bulk modulus is a reciprocal of compressibility. Usually in the strength of material, the two terms, two constant E and G are frequently used. K has a significant importance in the study of fluid mechanics. Next term is the relation between these three constants. The relation between E and K is, it is given by E is equal to 3K into 1 minus twice mu. Relation between E and G is E is equal to 2G into 1 plus mu. And E is equal to 9 kg upon 3K plus G. It is relation between all three constants, where E stands for modulus of elasticity, G stands for modulus of rigidity, K is the bulk modulus, and mu is the Poisson's ratio. For more updates, you can visit to my professional website www.engineersfirst.in, where you came to know about how you can make your engineering career more excel. What are the opportunities in engineering? How to prepare for the national examination like GATE. How to prepare project report, and many interesting things. You can also see this video, browse the more videos from my official YouTube channel. It's Ashish Lande YouTube. You can search in Google Ashish Lande YouTube. You will came to know there are n number of videos associated with the many academic topics. Basic intention of creation of this video is for the betterment of the students, not for the commercial purpose. So the video is basically created for the academic purpose, not for the commercial purpose. Intensive care is being taken while making this video, but still error is too human. If there is an error, please let me know. You can contact me on my mail ID. It's arlande@kpwap.edu.in. Thank you very much for your patience. Life.